Good morning, everybody. Today's video, we're going to actually be reviewing a couple of different ideas. Basically, we've got 4 different things that we've talked about that we know about triangles that we can use to help us find missing things in triangles. Today, they're going to be just finding one thing at a time, but kind of using those different tools and reviewing those different tools. Next week, the goal is going to be that we're going to combine all 4 of these things together to be able to find every missing thing in a triangle. It's called solving a triangle. Today, you're just going to be finding one thing using one method, but I want to just take today and kind of practice those methods. It's stuff we've done before, but we just want to review those things. So at this point, if we just talk about the things that we have talked about before, that's our goal. Review everything we know about finding missing measurements in right triangles. Yesterday and Wednesday, we talked about SOHCAHTOA, using that to solve 4 sides of a triangle. On Tuesday, we did inverse trig, so inverse sine, inverse cosine, inverse tangent to be able to solve for an angle. Last chapter, we talked about Pythagorean Theorem, and then the easiest one is the triangle sum, knowing that the angles of a triangle have to add up to 180 degrees. So we're going to start off pretty easy. If I asked you to find that missing angle there, we're not even going to need to use trigonometry because we don't even have any sides, first of all. But what we do know is if I took all of these angles and added them up, I would get 180 degrees. Now we do need to remember that this symbol right here, that right angle symbol, that means 90 degrees. We've got 30 degrees there, and we're trying to figure out what's left. Now we're going to do the exact same math as if we had $180 and we spent 90 of it on some new shoes and 30 of it on a hat. How much would we have left? We're just going to subtract. So I'm going to start off with my 180. I'm going to take away the 30 that I know there. I'm going to take away the 90 that I know there, and I'm going to see what I get. Now, if you feel like you want to do that all in your head or do it on paper, you can go ahead and do that. But remember, we've got calculators. So I'm going to take 180 minus 30 minus 90 and get 60 degrees. So that tells us that theta is 60 degrees. Right? That is kind of the easiest one. If you've got the angle and you've got the 90, you can find that other angle just by subtracting from 180. So pretty straightforward on that one. The second thing we've got, here I've got 2 sides and I'm trying to find the third side. I don't have any angles, so I can't use sine, cosine, or tangent because I don't know the angle. But what I can use is the Pythagorean Theorem. So as a reminder, the Pythagorean Theorem, a squared plus b squared equals c squared. We wrote these down in the very front page of our notes packet, so you should have this there. If you don't, go ahead and add that. A and B are going to be our 2 shorter sides, our legs, and C is going to be the hypotenuse. Unlike with trig, it doesn't matter this time which one is A or which one is B. I'm going to go ahead and make 12 my A, so 12 squared plus B squared equals 17 squared. I want to go ahead and square those, so 12 squared is 144. 17 squared, I'm going to my calculator. So calculator says 17 squared is 289. Then since I want to solve for B, I'm going to start subtracting. There's another place where I'm just going to go to my calculator here. I'm going to take the previous answer minus 144, and it says it's 145. And we will square root to get B by itself. On these, we are going to just go decimals. Anytime we're in trigonometry, we are not looking for mathematically exact answers. We are looking for decimals. Sides are always going to go to the nearest tenth for me. And so when it says 12.041, I'm going to go 12.0. I do want you to include that 12.0. So you can have your chemistry teacher in the future explain why we might do that. But we're going to go 1 decimal place. Actually, don't ask your chemistry teacher. They'll probably be mad that I include that decimal place. Mr. Ballard can explain. So we're going to go 1 decimal place, 12.0, because it wouldn't have rounded up. Next one. This time we are finding an angle. You can see theta there. That is the angle I don't know. But we don't know the other angle, and we have sides. If I have the 2 sides and I don't have the other angle, now I can use my sine, cosine, and tangent. I'm going to start here by identifying my sides. This one is the hypotenuse. This one is the adjacent. And so if I remember, I'm going to use, of my SOHCAHTOA, since I have adjacent and hypotenuse, I'm going to use cosine. And so the cosine of my angle theta is 15 over 20. And if you remember, the way I get that theta out is I use the inverse cosine. So theta is the inverse cosine of 15 over 20. The way to get an angle back is to use that inverse cosine. Now, you're not going to know what that is without a calculator, so you need to come over here and grab your calculator. Under the function tab, you've got inverse cosine, 15 divided by 20, and it says it is 41.4. Angles, we are just going to go to the nearest whole degree, so we're going to go 41 degrees. Okay? And then the last one is the stuff we were doing yesterday. If we have an angle and we're trying to find a side, we're going to want to use our normal old sine, cosine, and tangent. So I'm going to go ahead and just write SOHCAHTOA at the top. You have this in your notes, so you might not want to do that every single time. But now I can label my sides. That's the opposite. That's the hypotenuse. So I'm going to use sine. This time I know my angle is 68. My opposite side is 6. My hypotenuse is x. So I've written my equation. I think that was step 3 on those steps that you had in your notes. Then I'm going to cross multiply. X times sine of 68 equals 6 times 1 is 6. And to get x by itself, I'm going to divide by sine of 68. At this point, I've solved for x, and I can type that right into my calculator. So I will pull my calculator back over onto the screen if I can figure out where my mouse went. There it is. So I'm using normal sine of 68. Nope, sorry. I forgot what I wrote. 6 divided by sine of 68. So 6 divided by sine of 68. Calculator says 6.47. So we're going to round that to 6.5. Nearest tenth for sides, whole degrees for angles. So that was pretty quick, but that's stuff that we've already done. Feel free to look back. There are videos of especially the trig problems, so finding an angle, finding the side, on Tuesday and Wednesday's Canvas page. You can always look at those. But for the homework today, you've got about 20 problems. Some of them are about, some of them are the really fast ones where you've got to just find the missing angle, or you're using the inverse sine, inverse cosine, inverse tangent to find an angle. The other half are the ones where you've got to use Pythagorean Theorem, or you've got to use sine, cosine, or tangent normally. And those are going to take a little bit longer. But just like before, the answers are all at the bottom. So please check as you go and make sure you're showing your work. I should see work that looks pretty much like this, depending on the type of problem that you're seeing. So you're working on that the rest of class, and I will see you on Monday.